Okay, so now we will be starting discussion on the topic adsorption, which is a mass transfer operation. Okay, adsorption. Basically, according to BTech students, it is the adsorption we will be discussing today. Mass transfer operation. So basically, first of all, we need to know what is adsorption, what happens in the adsorption, and what are the important points that we need to remember in the adsorption. First of all, what do you mean by adsorption? Adsorption. Adsorption is the process in which the solid on which the fluid gets attracted, or on the solid on which the solute particles from the fluid mixture gets settled is known as adsorption. Basically, it is known as fluid solid separation. Fluid solid process. Basically, adsorption is a fluid solid process where the fluid, the solute particles of the fluid consists of a solute particles. Fluid consists of solute particles. So basically, the solute particles of the fluid get settled on the solid particles. This process is known as adsorption. And this solid particles or solid bed or solid material on which the solute particles of the fluid get settled is known as adsorbent. It is adsorbent. And the fluid particles or the solute particles of the fluid might be liquid or a gas, anything. The solute particles of the fluid that settle on this solid compound or adsorbent are known as adsorbate. So these are the very two common terms that you come across in the entire unit. So basically, first we need to understand these two terms. Okay, so adsorption is generally a fluid solid process where fluid may be a liquid or a gas. It is a process it is a unit operation or a unit process in which it's basically a unit operation in which the solute particles of the fluid get settled on a solid material. It is a unit operation. It is a unit operation in which the solute particles of the fluid, whether a liquid or a gas, get settled on the solid material. This process is referred as adsorption. Basically, adsorption includes two parts, two main terminologies, which is adsorbent and adsorbate. So adsorbent is the material or the solid material on which the solute particles get settled. And the solute particles that get settled on the solid material are known as adsorbate. So this is what is the basic terminology that you need to understand. Now, before we start any of the process, we need to know the applications of such kind of processes, right? So let us see the applications of adsorption. Adsorption application. Generally, these adsorptions are helpful in fluidization. The first very important example is fluidization. The general example is fluidization, where the solid granules or solid particles are in contact with the liquid phase or the gas phase. Where the solid particles are in liquid phase or gas phase. The major application is fluidization. And if you come in practical point of view, the first applications we can take is separation of toxic substances and removal of odor from waste gases. Toxic substance separation of toxic substances separation of toxic substances, recover valuable solvents, to recover valuable solvents, and many more applications you have. You have many more applications from where you have to recover the solvent. You have to separate, for in some cases the solute particles might be separated from the fluid mixture, which is important, or the leftover fluid after the solute is get separated might be important. So based on the requirement, there are many applications of adsorptions. Now adsorption is basically classified into two types: physical adsorption and chemical adsorption. Physical adsorption and chemical adsorption. So basically these two are the different types of adsorptions which are different on the basis of the forces between the solute particle and the adsorbent, that is adsorbate and adsorbent. Basically they are different based on the forces that are present between the adsorbate and adsorbent. The forces of attraction between the adsorbate and adsorbent is very important, because you have if you consider a solid particle, on that you will have solute particles which get settled, right? So if this solid particles or solid material, you say, have a weak forces of attraction, basically they are physical forces which are known as van der Waals forces of attraction, basically which are van der Waals or weak forces of attraction, then these solute particles can be easily separated by the process called adsorption, which we will discuss in the further. So this is what is important. So basically if the forces of attraction between these two, that is the adsorbate and the adsorbent, is weak, which is generally known as weak van der Waals forces of attraction, then it refers to physical adsorption. If the adsorbate and adsorbent are tightly or are having a very strong forces of adsorption, generally they are chemical forces or generally binded together by chemical bonds, you can say strong forces generally known as chemical bonds. But remember, in chemical adsorption they are binded together with some chemical bond, but there is no chemical reaction. This is very important, there is no chemical reaction. So if the adsorbate and adsorbent are binded together, or these adsorbate are settled together on adsorbent by a strong forces generally known as chemical bonds, and there is no reaction between these adsorbate and adsorbent, then such process refers to chemical adsorption, and in this kind of adsorption there is no irreversibility. That is, once the solute gets settled, you cannot separate that. Either you have to go for different treatment methods for the separation of this solid material, solute material from the solid. We are having strong forces of attraction. This is what is that there are difference between physical and chemical adsorption. So basically adsorption is classified into two: physical and chemical adsorptions. Physical adsorption is nothing but where the adsorbate and adsorbent have weak forces of attraction, generally which are van der Waals forces of attraction, and which are generally physical, is known as, that's a process known as physical adsorption. Then comes to chemical adsorptions, when the adsorption phenomena takes place when there is a very strong force between the adsorbent and adsorbate, then such a process is known as chemical adsorption, which have a strong forces of attraction between them, generally known due to chemical bonds, but there is no chemical reaction that takes place between these two, and this process is generally irreversible. Now we have to see how, on what basis and on what basis do we select the adsorbent, and what should be the nature of that adsorbent. What should be the nature of this adsorbent and on what basis we select this adsorbent is our main task. So now we will discuss the nature of adsorbent. Nature of adsorbent. So first one, they must be in a granular form. The adsorbent must be in the granular form for proper separation. They should be in the granular form. They should not be a stiff body, because if you have a steel or something metal body or any other solid body, the fluid will come in contact with it, but there will be no separation taking place. But if you have granular nature, the solute particles get settled on this, and due to the porous nature of it, the unwanted particles will be flowing through the space between these granular particles. So the nature of the adsorbent must be granular nature. They must possess a high surface area or large surface area. They must possess large surface area. The surface area should be large, so that more adsorption and quality type of adsorption takes place. Accurate adsorption takes place. Proper adsorption takes place. For that you require large surface area. Next, they must possess a proper ability or preferential ability. Proper or preferential ability for adsorption to occur. Means the adsorption to occur, the solid body or the solid granular material should have the ability to allow to settle those solute particles and flow away, let the flow of unwanted particles to move from the solid material. So basically, if the adsorbent has a very larger granular materials, if you take, then the adsorption might be different, because if you have larger granular sizes, then what happens? The solute that is there will not get settled on this along with the solute. Whatever is getting settled on this adsorbent, along with that, the unwanted solvent or unwanted material also sometimes gets settled on this materials because of the large size. Because if the size is increasing, the space will decrease, so the unwanted material cannot flow easily. So indirectly it should have a preferential ability or proper ability for the process to occur. Next is, it should be porous in nature. Next, it should be porous in nature. The solid must be porous in nature. Means it should have space, or it can, porous is nothing but holes type of thing. Very minute holes it should consist of. Best example, you can take a duster. Duster is having some minute amount of holes in it, right? If you have some chemical color and water, right? So what do you do in that? In such case, we will have, if you take a duster or a sponge, you can take. On that sponge, if you pour a colored material or colored liquid, the color will get settled onto this, and because of the porous nature, some of the material falls down. Or when you wet, if you have a sponge, when you wet it, and when you try to squeeze that, what happens? The liquid starts dropping out from it. That is because of the porous nature. Indirectly is nothing but, porous nature is nothing but holes. It should have some space for the solvent or the unwanted material to flow through that. Next one. Next one is, they should have proper adequate strength and hardness. Proper adequate strength and hardness. Like if you have a very lightweight material, then what happens? Lightweight solid granules if you have, if you are going for a bulk fluid, what happens? The fluid will flow at a stretch. You cannot float the fluid drop by drop, right? So at a stretch the fluid will be falling onto the granular substance or the solid material. In such cases, this granular substance or the granular solid material should be in the capability that it can withhold or it can withstand this flow. And it should be harder enough so that it can withstand this flow. Otherwise what happens, along with there will be disturbance in the positions of this material, and sometimes due to heavy flow the solute particles will get misplaced from the solid. So there should be proper adequate strength and hardness for the adsorbent. So basically the nature of adsorption is nothing but the solid material should be in the granular form, it should have a large surface area, it should have proper and preferential ability, means it should have adequate amount of space required, and it should be easily flowable. The solute should be easily flowable through that, so that you have a proper separation. And the solid material or the granular material should be porous in nature, so that the unwanted particles get separated from that, and it should have adequate strength and hardness so that it can withstand any kind of flow and situations that are required. Okay. So this was the introduction of adsorption. So once again I just introduced everything regarding adsorption. Adsorption is basically a fluid solid separation, fluid solid operation, where the solid material or the solid material that is used for the process is known as adsorbent, and the solute from the fluid that gets settled onto this adsorbent is known as adsorbate. Okay, and basically adsorption is classified as physical adsorption and chemical adsorption. Physical adsorption is nothing but the force of attraction between the adsorbate and adsorbent is weak. Generally generally they are known as physical forces, which are also known as van der Waals forces of attractions. Van der Waals forces of attraction. Then such process is known as physical adsorption, and chemical adsorption is the process where the forces between the adsorbate and the adsorbent. The chemical process where the adsorbate and the it is a process where the adsorbate and adsorbent have a very strong forces of attractions, generally due to chemical bonds, but there will be no reaction taking place between the adsorbate and adsorbent, and this process is irreversible. This process is irreversible. And you have various applications based on the requirements. You have various applications for adsorption, and the nature of the adsorbent should be selected. For nature of the adsorbent, that is should be the nature or the properties that the adsorbent should possess for proper adsorption are, it should be in the granular form. It should be granular form. It should have porous nature, means space, holes in it. Granular form, porous nature, proper strength and hardness. Proper strength and hardness to withstand any of the any situations. It should be proper. It should have the ability it should have the ability for the flow for the adsorption to take place. So these are the different nature or properties of that the adsorbent should uphold, right? So this was the introduction for adsorption.